like FaceTiming.
All right, so now we can do it again for this one. I go big G, little r, little r. So let's go first. That'd be big G, little r. If I go outside, I'm looking at big G, little r. If I go inside, I'm going little g, little r. And if I go last, I'm going little g, little r. If I look at those chromosomes that I have up here, again, it's pretty much like going heads, 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 tails, tails, heads, and tails, tails. There's 4 possible combinations I can make using these alleles. And what this represents overall is the law of independent assortment. That these alleles are going to assort themselves independently of each other into gametes. So let's plug those in over here. And I shaded the circles so that you can kind of know where they're supposed to go outside this really big Punnett square. All right, so I placed my information for my possible gametes outside my Punnett square. And it's a little bit bigger Punnett square because we're looking at 2 traits. We have double the amount of sperm or egg, so we have to account for each possible combination between each possible sperm and egg. And if you think about it, if you just turn it to the side, you have a lattice. And that should be familiar to you from everyday math. But Punnett squares, hey, they're square. So we just have to fill in each box in order to make a possible offspring. So we fill in just by meeting our boxes. And so I always like to go capital letter first and make sure that my letters match up so it's easier to read. So this one's going to be heterozygous all the way around. This one, again, I'm just filling in as I go, so it's easier for me to interpret what each one is. So I've done the first row. So it'd be basically if this sperm met each of these eggs, these are the 4 possible offspring I can make with just that sperm, but I need to repeat for the remaining 3 for each of the 4 possible eggs. So let's do that. Okay, I've completed the next 2 rows. I'm going to do the last row with you so you can kind of see again how it works. I have to take this egg all the way down over here and then fill it in with that sperm to make that baby. I'm going to do it again for this one. Now that I have this set up, I need to figure out all of my genotypic genotypes I can possibly make. And so I have to go through each of these boxes and start seeing which ones look alike. And the easiest thing to do is to color coordinate them. It's easier to go back. So any box that's big G, big R, I'm just going to shade quickly red. So I got those done. Now I'm going to pick blue, and any box that's big G, little r, I'm going to shade them blue. Any box that's little g, big R, I'm going to shade those purple or not. And then that lets me see that I have 4 boxes that are completely homozygous recessive. And so I'm going to identify these and write them down here so I can count them up to do my ratio. So I have 4 of these, I have 4 of these, 4 of these, 4 of these. My ratio would be 4 to 4 to 4 to 4, or I could reduce it down to 1 to 1 to 1 to 1. Now, what are these gonna look like? Well, these are gonna be green and round. These are gonna be green and wrinkled. These are gonna be yellow and round. And these are gonna be yellow and, did that wrong, didn't I? Can't have two of those. Sorry, it should be a lowercase r. Green, yellow and wrinkled. So there's 4 possible genotypes. So let me write those out as well. So I got green and round, green, wrinkled, and then I'm going to write this over here, yellow and round, yellow, and let's remember that's a small r because I goofed, yellow and wrinkled. You always need to include both traits. It's a dihybrid. You just can't say green and then wrinkled around. It's green and round, green and wrinkled, yellow and round, yellow and wrinkled. And because it's still 4 to 4 to 4, my phenotypic ratio isn't any different than my genotypic ratio.